And we start.
Okay, thank you. Hello, everyone. Good afternoon. I'm so happy to have you all here with us today to discuss the third webinar, Explainability in Artificial Intelligence, Ensuring Transparency in Machine Learning Decision with Dr. Amro Najjar. So thank you for taking the time to join us for this webinar, and we look forward to your continued engagement for the online chapter and the online webinar. So before I start, before I give the stage to our speaker, let me introduce him. So first of all, thank you, Amro, to join us today despite the difference time between Luxembourg and New Zealand. I know that this session overlap with your mission in New Zealand for your conference. So thank you that you join us at this time. Thank you. So Amro Najjar is currently a researcher at the Luxembourg Institute of Science and Technology, LIST, where he is a senior researcher at the Trustworthy AI team. Before joining LIST, he was a postdoctoral researcher at AI Robolab and the SCR team headed by Professor Leon van der Dorp at the University of Luxembourg. Dr. Najjar joined the University of Luxembourg as a research assistant to work in explainable AI. Before moving to Luxembourg, he worked as a postdoctoral fellow at the explainable AI team in the University of Umeå, Sweden. Prior, he worked as a postdoctoral researcher in the Hubert Curien laboratory at the Jean Monnet University in Saint-Étienne, France. His main research topics were vehicle personal assistant agent, multi-agent negotiation, user-centric system, and quality of experience. He obtained his PhD in computer science from the École des Mines de Saint-Étienne, France. And we are honored to have him today to share his work, his knowledge, and his insight. So please, if you have, my dear participants, if you have any question, don't hesitate to write them in the chat. After the talk of our speaker, we will moderate your question to the speaker. And we will be recording. So we are recording as well this webinar. And for those who are unable to join us, or for those who want to rewatch it later, the recording will be available on the Redis platform. And also you have the possibility to write your question in the chat if we couldn't answer all of them during this session. So Dr. Amro, the stage is yours, and thank you.
Thank you, Sana. Thank you, everyone. I'm really glad, and thank you, Sana, for giving me this opportunity. And I'm happy today to be here. I'm trying to give this presentation on explainable AI. I gave this title, Interactive Embodied Explainable AI, but please consider this presentation first and foremost as an overview of explainable AI. And I try to make these slides in a way that is fits people with different backgrounds, but of course I'm not sure if I succeeded. So please, once you were in the question time, please feel free to ask any question. Okay, so let me start the presentation. This is the agenda, but let me first move to the original problem. So the original problem is that nowadays we have a system of machine learning called neural networks. So neural is like neurons. Neurons are these cells in our brains that compose our brain, and neural networks are some way to mimic these neurons in our brain, and we are using them for several decades. But since a couple of decades, or even less, since 10 years or 15 years, they became extremely powerful and successful. So we have them excelling in tasks like image classification, image generation, all this artistic image generation, generative AI, GPT, GPT-2, GPT-3, GPT-4, the new GPT that they released yesterday, also chess playing, Go, this Japanese game. All of them is somehow powered by machine learning, and more specifically mostly by neural networks. So they are very successful, but still they have their own limits and they have their intriguing outcomes. So intriguing in a sense, I will give an example later. And this is a very famous researcher that I put the photo of. He's Christian Sagadi he used to work in Google, but now he went back to Poland. He's originally from Poland, and he's working in the Polish Academy of Sciences. When he was in Google, he wrote a paper, very influential one, about the failure modes of machine learning and the intriguing results of this model of neural network. So for instance, here we have a panda. You add some noise, and then the network could classify it as a bird, or you add a different type of noise, and then it could classify it as a vehicle, and it's a panda. So even though it's very strong, it's very easy to mislead and very easy to deceive. Very easy yeah, I think to deceive, let's say. So which means that how can we be sure that what we are doing, and that these tools that are very strong are doing correct, or are giving us the right result? For this, in 2016-17, we have an initiative, mainly starting in the USA, talking that we need to do explainable AI, and that we need to see what's going on inside the neural network. That's the main idea. So we understand why, and we understand why not. We understand when did the system succeed, when did it fail, and so on. So that's the main idea. Here I pasted a very famous example. It's as you can see, some of the photos are photos of muffin cakes with blueberries. Others are of Chihuahua dogs. And machine learning at the time, an up-to-date machine learning, cutting edge one, was not able to distinguish between a Chihuahua dog and muffin like this. So and then what we need is to know why, and we need to understand where it is failing. And this leads us to an explanation. Because what is an explanation? Well, people in philosophy and in social sciences refer to explanation as numerous ways of exchanging information about a phenomena. So, and in our case, it's about a model or a decision model, that is this neural network. And what were the rationale or the criteria for a decision, and explaining this decision to different stakeholders. So in our context, an explanation could boil down to this why question. So why did a neural network classify a muffin as a Chihuahua or vice versa? And this is how explainable AI emerged again to the as a very important field of research. Okay, so but I'm saying emerged again, and here the word again is very important, because I'm saying I'm mainly talking about explainable AI in its current form. As I showed you, it's people from Google, it's about neural networks and so on. So this is rather a new phenomena. We want to explain these new neural networks. But if you dig a bit in history of science and of computer science, well, you find that explainable AI is not new, because between the 1970s and the 1990s, another type of AI was prosperous, and this type was expert system. So expert system, for instance, there was a very famous system in the 70s developed by this guy to the right, whose name is Shortliff. And Shortliff was really pioneering in the 70s, because he developed something like the ChatGPT. It's completely different when it comes to the internal architecture, but it's something like the ChatGPT that is able of diagnosing a patient. So the patient could give the symptoms, and this system, which was a rule-based expert system, was able to say what is the illness of the patient, what is the patient suffering from. And not only this, it was also able to explain why it thinks that this is the case. So it was also explainable. But For those of you who are familiar with the research on AI, in AI we have this AI winters and AI summers. So AI summer is when everything is working on very well, or this is how it seems. This when we get lots of funding for AI. So now currently we are in AI summer. Everyone is talking about AI. AI looks to be very trendy. But in the history of AI, is not always happy. In some decades, we had what we call AI winters. So AI winters is where when people lose hopes or lose faith in AI and the funding stops. And this happened to this expert systems for different several reasons, and we ended up abandoning them altogether. And we forgot consequently about this explainability and all this explainable AI ideas. So they were just died. But and as I explained in the beginning of the presentation, today we have a new type of neural of AI systems. These are the neural networks, and as I said, the neural networks has been developed in the first place to mimic the way our brain works and to model the artificial neurons that we have in our brains. And as I told you, these are becoming very, very powerful. But as you can see from the figure, they are just becoming more and more complex with lots of layers. And that's why we call them deep learning, is because we have several and numerous layers. And in between these layers, we have numerical connections, and it's not possible for human beings to understand what what are the meaning of these numerical values. So that's why this neural network is considered to be a black box, and that's why we need to explain the black box. So, and that's why we are talking about again about explainable AI, because now it's no longer this rule-based expert system. It's this kind of sophisticated neural network full of sub-symbolic or numerical values, and the goal is to explain it. That's the main challenge of explainable AI. We are trying to explain the decisions of a neural network that, as I explained, is very powerful in something like image recognition, but still it can be mistaken, and it can classify a chihuahua as a muffin or a muffin as a chihuahua. Okay, so now I'm giving an overview of why would we need explanation in AI in general now in 2024. Why do we need this explanation? Well, we people in the literature had already identified four possible reasons. The first one is that we need to provide explanation because of relevant legislation. So now in Europe, for instance, people are talking about the GDPR. People are talking about the right to explanation. So I need, as a user, as a citizen, if explainable AI is going to play an important, if AI, sorry, is going to play an important role deciding my life, for instance, if I get a loan or not from my bank, then it's my right to get an explanation. Okay, so that's one. The second one is this is to improve the functionality of the system, because suppose that you have a self-driving car, and the self-driving car is not able to distinguish between a pedestrian and a panda with some noise, right? So this is a big problem. We need to improve it. And how we improve it? Well, by explaining the behavior of by understanding its behavior, and this means explanation. The third point is we need to help humans working with the system. So if you are, I don't know, if you are, for instance, someone who is working with a traffic simulator or with a autopilot or any kind of sophisticated AI system, having an explanation will help train you work with the system. And the last thing, and today we are going to detail this a bit later, is to build trust between individuals and the system, because we did some research, and it has shown us that when you have transparent systems, so systems that explain their behavior, this inspires trust between users and the humans. So this is today why we need explanation. 4 reasons. Okay, so Now I explained how explainable AI appeared, why today is a hype and hot topic. What I'm going to show next is a bite or a nutshell of the landscape of explainable AI. So in courses to my students, I tend to show this slide. It shows that actually today explainable AI is set, six type of domains. Each of these domains is almost independent, and each of them is independently or almost independently investigating explainability. I'm going to explain them quickly and briefly to you. And of course, later, please feel free to ask me questions. So, first of all, is explainable machine learning. This is what I've been talking about since the beginning. This is where we have these machine learning and neural networks. So, the typical tasks of this kind of systems is object recognition and object classification and pattern recognition. So I have here an example. Suppose that you have a system that tries to manage the rail network, and one of the basic tasks that you need to do is to recognize trains. So you will build a very simple program with a neural network that tries to recognize trains. So what is this photo? Is a photo of train? Well, yes. The question is obvious because we all can see a train, but the problem is, as I mentioned earlier, this neural network is a black box. So if we tell it why this is a train, it's not going to explain to us. So what we do is we train another model that is not a black box. So we train something we call white box, which is a decision tree, something like a decision tree. And this decision tree allows us later to explain the neural network or to provide an explanation that could be precise or not, but it is an explanation of why the neural network classified this photo as a tree. So this is the first and the most important trend in explainable AI, trying to explain the output of neural networks. Now, the second one is what we call explainable reinforcement learning. So for those of you who are not familiar with reinforcement learning, it's a very simple idea. You have an agent or a robot. It's like the Pac-Man. The agent, the Pac-Man, has a goal. It wants to explore the environment and it wants to reach the prize. Whenever it goes to a good position in the Pac-Man, it receives reward, so a positive reward. Whenever it sees the monster, or the monster is very close to the Pac-Man, then you receive a penalty. And based on this reward and penalty, the goal is to optimize the behavior of the Pac-Man and reach the goal. That's the basic idea of the reinforcement learning. But when the Pac-Man world in other applications, of course, gets so big, this becomes very complicated mechanism. So for instance, we have applied this technique to games such as the Go, the Japanese game Go, or also to chess, to robots, and so on. And you can imagine, for instance, in a chess or in Go, at each move that you can do, how many possibilities or combination of possible moves you can do. And you can imagine how powerful is this reinforcement learning mechanism. And how it works, as I said, it's about accumulation of reward and penalties. But when it becomes so complex in applications like Go or robots, it's very tough for users or even for programmers to understand why a decision was taken. So why, for instance, the chess engine decided to move the knight in the move 37 to some specific square. This is very difficult because it's about numerical values that has been accumulated and accumulated and accumulated. It's a very big tree, modeled as a very deep tree of numerical values. So that's why we need to explain the decision of reinforcement learning, and we are now developing approaches to do this. We have decision trees and reward decomposition and genetic algorithms. So this is more or less the story of this explainable reinforcement learning. Now, this is where Sana and we work, is explainable, is agents and explainable agents. So what is an agent? An agent, you can think of it as a robot, but it has no body, like no body, no embodiment, and it's a goal-driven entity. It's an autonomous software. It could, for instance, try to manage your smart home, or it could be the one managing your smart car or your fleet of cars. And we build it based on utility function and some kind of inspired from cognitive systems. And the idea is how to make this type of things explainable. For this, we have our models. If you are interested, of course, I can explain it. Please let me know in the question section. I just want you to know that this thing is useful. For instance, when you want to have a better human-computer interaction. So, for instance, suppose that you have an agent that tries to recommend you what to eat, as I can show you later in the example. An agent that recommends you what to eat. Well, the personalization, the explanation, sorry, that you need if you are a kid, 6 years old kid, is different than the explanation that you might require if you are a nutritionist. Okay, so that's one of the things that we study in this community. The next community is almost the same, but when the agent is embodied as a robot. So it's not a virtual agent, it's not something like the GPT or a chatbot, it's more like a robot. And not only a robot, it could be also a remote robot. So that's why I put the image of the picture of the UAVs, the drones. Drones, suppose that you have an AI system that is managing your drone, or that is managing a rover on the moon or on Mars. So in this case, the robot, you don't see it next to you, right? You don't see where it is, which means that you don't know what are the decisions that it is taking, and you don't know if they are the good decisions. It could be doing something wrong. You are worried about what kind of decision it has taken and how to correct it in case it's wrong, and what were the results of the decision and the actions of the robot. And that's why we did research on this topic, and we found out that remote robots needs their own explainability. It's just like when you are talking to a human being. When the human being, your friend, is in front of you, sitting in the same room, you need less explanation of what he's doing. But when he's remote, you need more explanation. And this is the idea of this research domain, and we are working on this to make explainable and understandable remote robots, and to make them safe for human use. For instance, UAVs or drones delivering parcels and packages. Okay, so this is this branch. Now the next branch is very much used in industry and industry engineering. So in this domain, we have, it's called planning, and it's about, you have something like a factory, and it's like a production line, and you are in state S1. You want to move from S1 to S2, from S2 to S3, until you finish your product, your manufactured product. And this is to do this, you need planning. This community is an old community that is there maybe since 40 years, but now what they are trying to do is to make the planning taking into account the human. So suppose that you are in a factory setting. You have a factory where robots work with the humans. So the robot has a plan to I don't know, to assemble some pieces, and the human also has his own plan. How can they understand each other so that they can work and co-work in a teamwork, in a team, smoothly? To do so, this community is trying to do explainability. Of course, I can explain to you how it works, but it's just that before, what you need to understand here is that before they used to optimize the plan, they didn't take into account the existence of the human with the robot. It was just that the robot needs to be optimal. Now, what we are trying to do is we are trying to make the robot and the human work smoothly. And in LIST, we have such a project with French partners, with partners in France, about a factory setting in an industry use case, where robots and the humans are supposed to work together in an industrial application. Okay, so now I think this is the last one. So the last community of explainable AI, I think all of you are using it. So if you are using Netflix or if you are using Amazon, whenever you start browsing Amazon or Netflix, they start recommending you material. So for Netflix, they recommend you movies to watch or series to watch. For Amazon, they recommend product to buy. And the question is, why? So why am I getting this next film on Netflix? And it has been shown that this is actually very important because it influences your behavior, your buying behavior. And when it comes to news and politics, for instance, if you have a Twitter account or Facebook account or whatever kind of social network, the information you consume in them are also brought to you by a recommender system, and which means that this is going to influence people behavior before the elections and so on. And that's why, especially for legal and political reasons, everyone, I mean not everyone, but many people are pushing to do this explainable recommender system and to make these platforms like social networks more transparent and allowing us to understand what is the source of information and why this information has been shown to me. That's the last one of the branches. I just want to, so this is what I was explaining to you. Now if you remember the different types of explainable AI, this means that you have a course or you have a general idea of what explainable AI is. All of these small pieces is explainable AI, the sum of all of these. So that's what we are doing now. Some challenges that we are facing in this domain. I think the first one is the obsession with the black box. So as I told you, what is the black box? Is this neural network that I showed you earlier. I'm going to go back to the slide. This is the black box, is a full of artificial neurons. It's a black box because we cannot understand what's going on inside and why it has fired a decision to consider that this is a chihuahua or this is a dog. So it's a black box, and that's the problem. Now our idea is people has been obsessed with this black box. It might be actually impossible to understand what's going on. It's like even for a human brain, like if you, or even let's say you have an animal brain in front of you, you don't understand what's going on inside the brain. I mean, even if you look at the brain, you will not understand what's going on because it's very complex and very complicated. So at some point, maybe we need to reduce a bit our obsession with seeing the black box or opening the black box, and we need to care more about the user. So we need to talk about fair AI, ethical AI, and accountable AI. And we need to go beyond this opening of the black box towards more user-centric AI. And that's a very trendy business. And it's an interdisciplinary approach followed by researchers in AI, but also in law and in ethics and in many other related domains. And we think that it's very important for us to understand, to answer some of the questions about the AI. So for instance, about who is setting up the who is deciding, why the algorithm, so who, why, and where, and all these kind of decisions. And the solution for this would be to involve different communities from people with different backgrounds. That's for us, this is the key for the solution. So this is the main challenge. And to solve this challenge, we have two ideas that we are pursuing in our labs in Luxembourg. The first one is talking about interactivity and explainable AI. So interactivity is what? Interactivity for us is just you look at the way you explain phenomena to your friend or even to your kid, to 5 years old kid. How do you explain a phenomena? It's never one-shot explanation. It's always an interaction. It's always interactive. You explain something, and then the recipient of the explanation either asks another question or asks for more information or shows that he understood or shows that he didn't understand or she didn't understand. So that's the idea. It's an interactive process. It's not like what we are doing in AI now, in the traditional explainable AI approach. It's more like a dialogue. And this is where we are moving in the domain on dialogues of explainable AI. I mean, it could look simple, but in reality, it's very complicated because dialogue means, there's logic behind. There's also linguistics behind. There's also, different type of natural language understanding and processing behind. Just to understand how it's complicated, just recall how many times ChatGPT misunderstand your request, especially when it becomes like you are in a sequence of interaction about the same topic. So now we are trying to do this. Yeah, so I gave an example. Maybe it's not the time for this. Now, the second uh, research trend that we are moving to do is this embodied XI. So embodiment, when in AI, whenever we use the term embodiment, it means robots. So as you can see here, for instance, the robot is explaining something to the human, but when you explain something to the human, or even when us as humans explain phenomena to each other, we rely on the body. We rely on the body language. We rely on facial expressions. We rely on pointing and on this kind of things. Even emotions. Emotion. This is research. How we show this. This has been demonstrated by scientific research that emotions also play a role in explanation and in receiving explanations. So anything that you can think of, it could be helping the explanation process. It could be gaze, it could be the head orientation, it could be the facial expressions, it could be the intonation of the voice. So that's the idea of this embodied XI. What we are trying to do here is we are trying to make robot learn from the way humans explain. That's the main idea. And to do so, of course, we need to have a robot. The robot needs the hardware of the robot need to support some things. It needs to be you know able to make facial expression and able to point and able to move and so on. But this is challenging, as you can see, as I will show you later. It's a challenging business because these robots are still in really their early days, and they are more like infants or toys. You will see this in the example. Now I need to move to the next slide. Yeah, so here I'm just pasting some examples of robots like this yellow robot who tries to explain and give you a more persuasive explanation using some vocal cues. So the way it talks and the intonation, and also it could point about something. So for instance, you can see the photo to the right is when the robot misunderstand you or is asking for a question. So all of this has been validated by studies that shows that when the robot is actually making this kind of cues is much better than without cues, or much better than just a chatbot without body. And that having a body improves the trust and acceptability of the system. Okay. Now, yeah, so this is, I think, another example of a project. I don't want to enter into the details of the project. So, but this is another project where we are trying to give explanation for remote robots. This is a parcel delivery system in a smart city. The idea here is that you have drones. The drones collaborate to give to deliver parcels, like packages. And when they fail, or when they succeed, or when they collaborate or not, everything they do should be explained to the human operator. That's the idea. This is also an explainable AI project. Here, before I move to the bigger example, I also pasted the photo of the project that I show you in France that we are doing with the Université Lorraine. And here is the factory setting. The pictures are in the factory, and in this factory we have robots, but we don't have the human but yet. But the idea is that this kind of robots in a factory setting, yeah, suppose that it's a car manufacturing scenario, and the idea is that humans and robots work together to collaborate together to achieve a task. For instance, to assemble a car. This is the idea. Now let's go next to see what we have. Yes, this is a detailed example of the reinforcement learning, how we are doing the reinforcement learning. Uh, yeah, this if you are interested in this is a project about ethics and explainability and AI. I can explain it in the later. Yeah. So the last before I move to the main example, the last small example I'm going to show you here is a very new one. So this is these are scrolls from the library of the stepfather of Julius Caesar. So Julius, the stepfather of Julius Caesar, lived in a in Italian city called Pompeii in the south of Italy, and I think around 70 BC, so 70 before Jesus Christ, a volcano called Vesuvius erupted, and it burned everything in the city with ashes. So it like the city was buried under ashes, and the stepfather of Caesar had a library of scrolls, and this is the photo above is one of these scrolls, and they got completely burnt, but they are still there. Now we want to know what's inside, but it's very difficult because if you touch these scrolls, they instantly get destroyed because they are very fragile. After a while, they developed a technology of scanning them, so we have them scanned, but we are unable to read because the material is very damaged to a very high degree. It's irreadable, and that's what when people in the Silicon Valley and several researchers in AI and in old Greek, because they are written in old ancient Greek, started to think, why don't we use AI? And that's the idea of the Vesuvius challenge. Not only AI, we are also now using explainable AI. So the explainability explains the output of the system to the ancient language expert, and this helps creating synergy between AI and this history's expert. Without explainability, AI can work alone and the expert alone. With explainable AI, they can collaborate or cooperate in order to achieve something. And actually, this is what happened partially. We didn't manage to read a scroll, as was the case requested by the challenge. But some students, I think in Germany, one of them, and the two others in the USA, they succeeded in reading 3 lines, and they won the prize. I mean, not the full price, because the full price was to read the scroll. The prize was $1 million, but they succeeded in reading 3 lines, and I think they got $300,000. And the challenge was not cancelled. It's now again, ongoing until the end of the year. So this is where one of the examples of explainable AI, what we could do now. Now, let me give you an example with a robot. This is the example that I'm going to detail. So this is a project that we are working on. It's a Chistera project, so it's kind of a European collaboration. It's funded by FNR in Luxembourg. It involves the University of Luxembourg. It involves LIST, and it also involves other partners from Switzerland, Italy, and Turkey. The idea is that what we want to do, we want to develop a recommender system for nutrition. So, for instance, either you use it to improve your diet, or also user with special needs, user with allergies, or user with diabetes, or with any kind of special need could use it to make sure that they are following their diet. Okay, so it's here in this case, explanation is very important. So the AI could provide you a recommendation. This is already, of course, the case. It has been around for several years. But what is new is that in order for you to get convinced about what you are getting as a recommendation, you will get also an explanation. And this explanation tries to be convincing and transparent, telling you why the system thinks that this is what you should eat in your next meal. That's the idea. This is the you can see the protocol on the top left. This is on below, we developed something we call ontology. And on the right, you can see the interface of the system. Okay. And then here is the example. I think, Sana, you told me it works. Now, what I want you to see, this is the current technology of the robots. What I want you to see is, I want you to see the limitations, so how it works and its limitations.
Hello, my name is Melissa. I'm a nutritionist. I'm here to help you about your food selection.
Yes,
Great, I can hear you too. Now, I recommend you eggplant salad with tomatoes. Not easy, I think it's a peculiar and delightfully affordable option. Did you like this recipe?
no,
Oh, I'm sorry to hear that. Do you want another recipe?
yes,
Before requesting another recipe, would you like to give me a feedback?
yes,
Okay. You can give me a feedback about recipes. I'm listening.
I don't like onion.
Anything to add?
I don't want to give any further feedback.
Now you can give me a feedback about explanations. I am listening.
I don't want to give any feedback.
Can you learn about potato dish? Not easy, I think this food concoction caters to your preferred taste. Did you like this recipe?
Yes,
Okay. I'm glad we found a good recipe for you. Do you want another recipe?
yes,
Before requesting another recipe, would you like to give me a feedback?
yes,
Okay. You can give me a feedback about recipes. I am listening.
I like the ingredients yogurt.
Anything to add?
I don't like dried mint.
Anything to add?
I don't want to give any further feedback.
Now you can give me a feedback about explanations. I am listening.
The explanation doesn't fit my case.
Anything to add?
I don't want to give any further feedback.
Okay, what about chicken, quiche, and watermelon salad? Not easy, I think this to learn recreational items of your taste preferences. Did you like this recipe?
Yes,
Okay. I'm glad we found a good recipe for you. Do you want another recipe?
no,
Okay.
Amro,
So yes.
sorry to interrupt you. Some participants couldn't understand the voice, the recording of the robot, what
Ah,
he is saying. If you can just conclude what was the
yeah. So
interaction or the experiment, please.
yeah, so actually, it's a good point to comment in any way. So, what was the interaction about? This is the food recommender system. And the robot was giving, in a combination with the screen and the robot talking, the robot was receiving information from the user about what the user would like as ingredients, and then giving a recommendation and also explaining it. I can share the video with you later. So this experiment is done by our Turkish partner, and this robot is a Luxembourgish robot called Qt that is created by the spin-off of the University of Luxembourg called Lux AI. So, and actually, this is interesting. We are doing this kind of experiments, and we are of course developing them. But also, one thing to see is that the interaction with the robot is not so smooth. And at the end of the day, not because of the robot itself, but because engineering the interaction between the human and the robot is a very challenging task, and humans could easily lose track of the interaction. That's why it's a very sophisticated task, and that's why in this example we figured out that it's better to rely on the screen. And it's frequently the case It's frequently the case that we people rely on a robot plus, a robot plus tablet, for instance. So we have this combination very frequently. Yeah. What else I wanted to add on this video? So as I told you, it shows the yeah, and so for now we think that the most potential category of users who will be interested in using robots are, for instance, children with diabetes. And this is actually why the robot has been developed in the first place, because this robot is specialized in, dealing with children with autism. But this technology still needs more to go to make the robot more, interactive and more engaging. And if you are interested in this, I would suggest that you go to this RoboCup at Home. It's a challenge that shows how different types of robots could be integrated in the home scenario, like in a kitchen. But it also shows the limit of the current technology. Okay. Now, I think we are running out of time. What I want to show you very briefly here, it's a use case example, but what I want to mention here is that the latest trend in XI is to use XI. So I get a system, I explain it with rules, for instance, or with any kind of non-user friendly explanation, and then I inject this explanation in GPT, and GPT or any kind of LLM, and LLM was going to create a nicer explanation for me. So this is kind of XI powered by GPT or enhanced by GPT or by LLM, and it's a very trendy topic. Everyone is talking about LLM, and we too in Explainable AI community, we are studying it. So that's this example in a nutshell. Yes. I hear talking about some challenges. This is our PhD student. She was talking about how explainability actually could be harmful sometimes, because it could reinforce our vulnerability to robots and to this kind of machines. If you are interested, let me know. I can comment on this in the question section. Now I think I'm reaching the end of my presentation. Sorry. I did lots of slides. So here why I'm now in New Zealand, because we are doing our yearly annual workshop in the one of the top conferences of AI. We have this workshop on explainable AI, and this is what we are working these days on: explainable agents and multi-agent systems. Yeah, so this is the why we are in every year. Also, we try to attract top keynotes, as you can see, and we are yeah, we did it last week, and that's all. And thank you for your attention. I think I'm on time, right? Because I wanted to
Yeah, that's perfect, Dr. Hamro. You are in time. You respected the time. Thank you very much for the interesting talk. We really enjoyed. So I see here we have some question to you. Let me just open the document. Here we collect the question. Just 1 second, Dr. Hamro. Okay, so let's go by the first one. So I try to answer as much as I can, but it seems that you have to go back to some slide to give your insight on it. So
yeah, I'm happy.
Yeah. Yeah. If you go back to the slide of reinforcement learning, search yeah, to the slide of reinforcement.
Am I sharing my slides, or I think I'm no longer sharing my slides, because maybe Sana, you stopped me sharing.
No, you're not. We are sharing the questions now.
Yeah, we will tell you the question. Just keep sharing your slide.
Okay, then if I want to share the slide, I need to be co-host. I'm not.
No, Amro, Sana.
Yes.
No, not sharing the slides anymore. We are sharing the questions now. In fact, the questions that we recorded that you are going to moderate now, Sana.
Okay, so yeah. We will see if Hamro can answer the question without going back to the
Yes.
slide. So, in your slides of
okay.
reinforcement learning, Serge is asking about reinforcement learning is not based in reverse engineering the model. Is that correct or not?
Reverse engineering the model. No,
Yes.
I mean, if I understand correctly the question, it's not really about reverse engineering. What we do for reinforcement learning is we define a simple set of tasks, of actions. So as I told you, for instance, if you know this Atari game of 35 years ago or even 40 years ago, it was a frog who is trying to cross the street. The name of the Atari game is a Frogger. It's a frog who is trying to cross the street. And the actions that the frog can do are very simple. So it is either you move forward, or you go to the left, or you go to the right, or you move backward. And in each time, how this reinforcement learning works is that for each type of action, in each position, we define a reward function. This function could be either positive, so it's good, or negative, so it's a penalty. And then we leave the frog try to learn on its own how to optimize the reward and when to move forward depending on the cars and so on, and how to move backward and so on. Of course, as I show you in the example in the slides this was a slide that I show very quickly. This was trying to use reinforcement learning to teach an arm of a robot, and the robot will do something like this in the beginning because it's not going to understand. It's just going to try all the possible combinations, but slowly it will converge. The same applies for the frog. The frog is going to try very painful combinations in the first 5,000 times. It's going to be run over by the cars, it's going to die, and so on, and then it's going to try again, until it learns a policy, an optimal policy of when it should cross the street and so on, and depending on the cars and so on. Now, this policy is a sequence of numerical values that we don't understand. Why the frog took the action at time t is actually determined by numerical values, and without explanation you cannot explain, like you cannot know why. Explanation will try to come and tell you, well, it actually took this because of this numerical values, which means that it was trying to avoid the car that is coming from the other side of the street, something like this. I don't know
Thank
if
you. Yeah, a little bit. This is what I've said. I've said that reinforcement learning is a type of machine learning that learn from mistake, that differ from the other machine learning algorithm that learn from the data. And so I have a continued question by the same participant. So meaning that not trying to reconstruct a similar model, but with another approach like decision tree. What do you think about it?
so. Can you repeat the question?
Meaning not trying to reconstruct a similar model, but with another approach like decision tree.
Yeah, I think this is a very, very good question. So that's why so it is true. Yes, it is true. I confirm it is true. It's not reconstructing the model. It's not explaining the model. It's not opening the black box. It's trying to construct another model and trying to explain the first one by using the second model that we think is easy to understand. Okay, so we bring a second model. We call it the surrogate model or the proxy model. We train it on top of the first one, and we try to explain the first one with this proxy model. And I think what you are pointing at is that it's not a faithful explanation. It does not explain how actually the decision was taken inside the first model. No, it's just what we call a post hoc explanation, and that's why this approach is sometimes criticized and attacked in the community.
Yeah, another question for the same participant. So he means that in particular that reinforcement learning is not embedding in the explainable AI by design.
Yeah, it is not. Also, explaining reinforcement learning relies on the same basic idea that we cannot explain the movement of the frog we train the frog with some kind of network or some kind of mechanism, and we bring another model that tries to understand this mechanism. And when we ask for questions, we answer from the easy model, not from the sophisticated one.
Okay, thank you. Another question from Mikhail. How we can say this robot for what is saying? How do we confirm that how do we confirm that the interaction was not programmed for its answer in advance?
Yeah, so we cannot, confirm, but it's robots. This is the
Yeah,
this is the this is
he mean there
experiment
is
done by this is experiment done by our partners. I think it's not pre-programmed in advance, but let's be more useful on the answer here. So look, robots now, when they are running and talking to the user, they are just relying on some kind of speech recognition. So the same speech recognition that is used by Alexa or by Google, you can put in the robot. So it's not a challenging thing for the robot to understand what you are saying and to answer you. What is challenging is the target application, which is in this case the food recommendation. So what's challenging is that the robot gives you the pertinent information that you need for the food recommendation and the explanation why the robot thinks this is useful. You get my point? So this basic or fundamental functionalities like speech recognition or like speech generation, they are not actually developed by us. These comes from libraries. They are almost the same ones used by Google or by Amazon. This is standard technology. What we aim for is to make it applicable for a specific domain, like for instance this food recommended system, or for other things like children with autism or care for the elderly, like in a case of a nurse robot. This is what is being researched, not the speech recognition. I don't know if I answered the question correctly.
okay. Another question from Alexander. On the scale from 1 to 10, Amro, where would you
Yes.
say, what would you say we are in terms of explainability of AI and why?
So it depends. But the scale, I think we are maybe at 4 or 5. But it depends because it depends if you think we are going ever to be able to explain the black box. Now there is this new, very very new trend of research called neurosymbolic AI. This is a new trend that tries to make neural networks, so this numerical architectures that I show you that try to mimic our brain, try to allow them to express themselves in logic. If we reach this situation, I think we are going to more to 9 maybe, or to 8. If not, I don't know. We will be more around 5 or 6, or people will say at the end of the day, maybe we don't need to open the black box. We just need to know how to interact with it.
Okay. By going to the slide when you showed the example of Chihuahua versus muffins, the question is about does the AI feel because it was not trained on enough Chihuahua like muffin? If there were many muffin like this in the training data, will it succeed?
Yeah, that's also a good question. So I think it works as follows. So this model is not trained specifically on chihuahuas or on muffins. Another example by the example of the Polish researcher that I cited earlier, it's dogs and tomatoes. So sometimes it's chihuahuas, so dogs and muffins. Sometimes it's tomatoes and dogs. Dogs are there many times, but it's different scenarios. Yeah. So to go back to the example, it's not the system is not specifically trained on this. That's true. But on the other hand, I think if I remember the example correctly, this was ImageNet, so it was the strongest general computer vision image recognition system available. So it's and to know why it's a problem, even though the system is not specifically trained on chihuahuas and on muffins. Just think of us. We managed to to distinguish between chihuahuas, humans. We managed to distinguish between chihuahuas and muffins without a specific training on chihuahuas and muffins. That's the idea.
Okay, thank you. Another question. Is there difference between explainable AI, the one mentioned as abundant, based in expert system, and the new AI in the slowness of learning before obtaining convergence?
Can I see the question? So what is it?
Yes. Is there before the last one? Is there difference between explainable AI and the new AI?
What I don't understand is the part on the slowness. I think he referring to reinforcement learning. He or she. Yeah, there is difference. So there is difference because in the case of expert systems, what we have is thousands of rules. I mean, if you put all the rules and you sit maybe for 3 weeks, you can understand somehow why is this one is. You can also debug it, because it's a rule. If A and B and C, then D. And imagine that you have 10 of them. If A and B and C, and then if A1 and B1 and 2, so you have thousands of them. You can still understand somehow a nutshell how the system is firing and how it works. On the other hand, so this is before we go to the other hand, this is not a black box. This is a white box, but it's a system that is getting complex because we have loads of rules. On the other hand, what I show you in the reinforcement learning or in the neural networks is a different story, because in this story with the machine learning, with the sub-symbolic AI, we call it, or connectionism, we have an architecture or an engine that is by definition a black box. Even if I debug it, even if I open it like this, I put it on paper, I will not understand, because it's just about weights, about numerical values. It's not A and B and C. It's nothing. It's just numerical values that are put next to each other or after each other. So that's why explainable AI in this new phase is different, because it tries to open the black box. And I will tell you an example that could actually, I wanted to mention this in the slides, but I didn't have time. So look, for instance, we are in the UK, they were using a system for HR recruitment. People apply, submit their CVs to a system, and then the AI decide who is the best candidate for the position. I think it was used for hospitals in the UK's. And we discovered after a while that the AI system is systematically discriminating against women for this system. And why? It's not because the AI is discriminating against women. It's just because the AI, it has a neural network, and the neural network has been trained on data that shows that most of the managers of hospitals in the data set of the training period, which is, I don't know, between 1970 and 2000, were men. So it has assumed that in order, one requirement for you to be a successful management of a hospital is to be a man, which is completely not true, because this is discrimination. Being a man or a woman does not play a role in how successful you are in managing a hospital, right? So, but the AI, inferred this. It sneaked into the neural network because of the training. It's now inside the black box, and you cannot get it out. If it was a rule-based system like the expert system that I mentioned earlier, the old one, there will be a mistaken rule that if woman, then not hospital manager. And then you can remove this rule and your problem is solved. But in your network, it's not, because your whole system now is polluted and you don't understand why. And you need to explainable AI for you to explain to you why this has been considered as an unsuccessful manager. Last point, in this same example, in many cases, we figured out that the system is able to deduce women. So even if you submit your CV and you don't say explicitly that you are a woman, the system could still infer that you are a woman because of learning. So it has learned some kind of pattern to distinguish between men CVs and women CVs. I don't know. And then it manages to infer who is a woman and then to infer that this is not a good manager of a hospital.
That's
So
right.
that's why we need to be careful.
Yeah. Yes, we really need to be careful about that. Okay,
Imagine
another
also,
question.
other applications, like who is going to get the next heart or liver transplant, and imagine a system that is also biased.
I don't want to imagine that. Okay. Will the nutrition robot will able to determine a complex nutrition plan based on customer objective in the long term? Means several
Also
lunching.
very good question. It's very, very good. I'm happy actually with the questions. So this is a challenging thing. One of the big criticisms of all these systems is that what we are developing them, testing, is only short-term, behavior change. In order to do long-term behavior change, you need long-term experiments, and the long-term experiment could be something like 9 months or maybe 2 years. Of course, for some kind of systems, like for mobile apps, I was once in one system, the part of one system that is a chatbot that tries to help you to stop smoking. So in this case, on a chatbot, we managed to do experiments that go for month and month. But for the robots, it's typically one shot or two shot sessions of tests, and that's it. Because these robots are very sensitive, and very expensive equipment. You cannot do the experiment outside the lab environment. And Sana knows. Sana is managing a lab full of robots, and she knows, this kind of robots, and she knows how difficult it is to, it could easily get broken. And so, unfortunately, no, we don't, and we cannot for now do the long-term studies. And if some others are doing long-term studies, it's mostly with a very limited set of participants. So number of participants is like 2 or 3 or 5, which is not significant.
Thank you. Another question. Among other aspects, explainable AI could help to better understand why a weird and correct output has happened, allowing us to improve the model in an iterative manner, implicating human feedback.
Yes, that's what we aim for, and that is what is we talk about in interactive XI, because as I said, explanation as a social phenomena, when you explain, when a human A explains to human B, is a social phenomena. We talk, it's actually never unidirectional, it's always bidirectional. So when you are explaining to someone, you also improving your understanding of the subject. So yes, that's what we aim for.
I'm happy to say a very deep question, which is good. So this is a question, but you can answer to it. It's about neural network, which is the topic of the coming webinar, but it's fine. Yeah, how do you set how many layers of neural net are needed for of neural network are needed for a specific AI system?
Yeah, so I don't have a clear answer for this.
Yes,
Maybe,
it's a engineer side. Yeah.
yeah, and also my impression is that what you do is you get an architecture and which is already made by some kind of a Python library, and you train it on the data, and either it works or mostly it's going to work, but you need to change some things. But I think the number of layers is never the big problem.
Yeah. Are there way of detecting bias in AI models? How could one detect biases at large scale without too much effort? Should AI model be certified as non-biased?
Yeah, very important question. So how can we detect bias at a larger scale? People are now, so we have algorithms called debiasing, debiasing data sets and debiasing algorithms. So we have now people working on this kind of things. But as you mentioned in the question, before debiasing, you need to detect bias. And how do you detect bias? Well, this is a big question. I know researchers in LIST and in the university also who are trying to use GPTs to detect bias in other GPTs because it's very complicated. So you need first to see how can you automate bias detection, and then you need to debias the system. Now, as I told you, this debiasing is a domain on its own. You have also pipelines and architectures that allows you to do this. Can we certify system as non-biased? This is a very important issue. This is also a legal issue because, for instance, suppose that I'm running some kind of an Uber app or some kind of restaurant recommender app, some trip advisor. If I am certified non-biased, this is very strong asset for me. So this needs to be, there should be a certification, authority. The non-biased system should have been tested and certified by this authority. And this is what EU is doing. Thinking about, not doing. EU is now thinking about this AI sandbox and regulatory AI sandbox, which is supposed to be a place where you bring your AI solution as a developer, and legal people and ethical experts and also AI experts are going to test your system and see if it needs any improvements, if it's biased, if it's not biased. And then probably at some point in time, we don't know how yet, you are going to say you are fair or you are non-biased to 8 out of 10. So this is a very hot topic, and it's a current research domain. Not only research, it's also a policy making issue. As I told you, EU is also looking at this. Japan is looking at this. Canada is looking at this. Many people are looking at this kind of things because this is a very strategic issue of this kind of non-bias. Who certifies, and what about trade secrets? There are many challenges in this.
Thank you. Is no bias not strongly depending on the data that was used for training the model?
Yes. So mainly, the bias comes mainly, but not exclusively, from the data. So very quickly, there's an article on Nature called "AI is Sexist and Racist, and it's time to make it fair." In this article, the author shows that if you bring one of the top performing image classification engines, it's going and you give it a photo of a bride from America and another bride from India, it's going to classify the bride of America because it's wearing the white dress and so on as a bride, and the other bride from South India or India is going to classify it as dance or ethnic art. Now, why? He tells that something like 70 or 80% of data sets available online come from North America and Europe, which means that the data used by these mechanisms are biased. Are not maybe not biased, but they are not representative of what's going on outside in the world. But please excuse, don't take my numbers precisely because they could be a bit outdated.
Okay, I think we have 1 minute to add the last question. Do there exist kind of adversarial network AI, which goal is precision and which is a black box, and explainable AI, which goal is to demystify the first one and be complete?
Yes.
I hope.
Yes. they are doing this kind of things. Now there are even I think what you are referring to is the generator generates a model, and the other one tries to pick the most explainable one, and it's an iterative process. So yes, now people are starting to look into this kind of systems. They call it a model zoo. The generator generates a model zoo, and then you pick up the best one, in an adversarial way.
Okay. Yes, please.
Yes.
Okay. I think we answered all the questions.
Is the last one on the yes, this one.
Okay.
So it's Rafael who's asking about the robot. So
Yeah.
yeah, so the
Okay.
robot
Yes.
is acting. Yes, the robot is acting by itself, but it's following a pipeline of behavior that is predefined. So it's like so the robot can understand whatever, not understand, but can recognize whatever you tell it. But if you tell it something that is irrelevant, it will just say, I didn't get what you need, please, and then it will take you back to the main pipeline of the predefined behavior. So there's always this kind of predefined behavior that is dependent on what kind of application you are doing. That's mainly the idea.
Okay.
It's
So
like
I
in
guess,
those programs, all those programs. Yes, sorry.
yeah, it's okay. Thank you so much, Dr. Hamro, for your talk and presentation. It was amazing to listen to you, and many thanks to the time you give it to us, despite the difference time between New Zealand and Luxembourg. Thank you so much. So, dear participants, I hope that you enjoyed today's webinar. Please don't miss the next webinar at the same day and time, which will be about deep dive into ChatGPT and the AI era skills comment by Dr. Shihad from the University of Qadiyat, Morocco. Yeah, so for those who want to rewatch the webinar, we will put the link of the recording in the Reddit platform. And if we couldn't answer the question, so I hope that we don't miss any of them. But please feel free to post them in the Reddit platform. And again, please be active in posting your question in the Reddit platform before the webinar. The question can be about the online chapter or the online webinar. I will try to answer them before the webinar. So thank you so much and see you next week. Thank you, Dr. Amr.